Okay, so today what we're going to do is solving one-step equations. You have seen this before. It's to solve equations by addition, subtraction, multiplication, and division. But it's a great place to start, and it's a good review. So some of the vocabulary is solution of an equation, equivalent equations, and inverse operations. So with this, a couple of things. You have the addition property of equality, which basically just means that whatever you do to one side, you have to do the other. So I could add 3 to both sides, and it's still going to stay equal. So if I had like 3 equals 3, I could make this be 3 plus 4. Well, that's still going to equal 3 plus 4. You have to do the same thing from what you do on one side, you have to do on the other in order to keep it equal. Same with subtraction. So here's the first page of notes. And this is using the addition property of equality. I'm not going to do all of these, but I'm going to do some so you can see what we should be showing for work. So this right here is m minus 10 equals 2. And so to undo the subtraction, to isolate this m, we want to get that by itself. What I need to do here is add 10 to both sides. Well, this is going to equal 0, so I can cross that out. And what I'm left with here is m is equal to, well, 2 plus 10 is 12. You can check that by substituting it back into the equation for your m. And 12 minus 10 does equal 2. So if we skip down to c, if you notice, what we want to try to get by itself is this b. And what we want to do here is we want to add 5 to this side and add 5 to this side. Well, that crosses out because it's equal to 0. So now I have b is equal to, well, negative 9 plus 5 is negative 4. I can check this by putting this back into the equation. Negative 9 is equal to negative 4 minus 5. So again, it shows you that negative 9 is equal to negative 9, which it checks out. Down below, we have using the subtraction property of equality. So here, in order to isolate this x, I would have to subtract 5 from both sides because right here I'm adding 5. That equals 0. That was our goal, is to make it equal 0. So I have x is equal to, well, 6 minus 5 is 1. I can substitute this back into the equation. 1 plus 5 is equal to 6, and it does work out. If you look at b, I want to isolate this y here, and what I have on this side with it is a positive 2/3. So in order to get rid of it, I need to subtract 2/3. What I do to one side, I have to do to the other. So if I go over here, I'm going to do this 1/4 minus 2/3. So we have to find a common denominator, which is going to be 12. And 1/4 is equal to 3/12, and 2/3 is equal to 8/12. When I subtract this, I am going to get a negative 5/12. So y is equal to negative 5/12. As I go through, here's a problem solving, and it says here, Brendan withdrew $25 from his bank account at an ATM. The transaction slip said his balance was then $243.19. Write and solve an equation to find Brendan's previous balance. Now you could solve this pretty quickly without having to write an equation, but since it specifically tells us that we need to write an equation, that's what we need to do. So if I start with my previous balance, we'll say that's x. He withdrew $25, which means he's subtracting $25. He took $25 out of his account. His balance was then $243.19. So now that we have our equation written, now we can solve for x. Well, I'm subtracting 25, so to undo the subtraction, I need to add 25. This will cross out because it's equal to 0. And then I'm left with x. I guess it's not going to let me write there. X is equal to, if I add all of this together, it's going to be $268.19. So this right here was my previous balance. Same goes for multiplication and division. So to undo multiplication, you have to divide, and to undo division, you have to multiply. So if you look right here at this example, it says n over 6 is equal to 5. And so what this is saying is a number divided by 6 is equal to 5. So with this, in order to solve for my n, in order to undo this division, what I need to do is multiply by 6. And what I do to one side, I have to do to the other. So over here, I'm also going to multiply by 6. That crosses out, and n is going to be equal to 30. The reason why this crosses out, those 6's cross out over here, is because if I was to take 6 and multiply it times n over 6, well, what that equals is 6n over 6. Well, 6 over 6 is just 1, so we can cross that out. On B, we want to solve for x, and it's being divided by negative 3. So we're going to multiply by negative 3 on both sides. Crosses out. X is equal to negative, well, 18 times negative 3 is going to be 54. Negative 54. And you can plug it back in and check it as well. C is a little bit different because the negative sign is out front. But in order to get a by itself, we want to get rid of that negative as well. So what we're going to do here is we're going to multiply by negative 5. This crosses out. It also crosses out that negative there too. So I'm left with a is equal to, well, negative 20 times negative 5 is 100. So now if we go down to using reciprocals, this is the part where I think it might be a little bit new for you. You might not have seen this before. But if I said to you, if I had 2/3 times 3 over 2, if I multiply this, so 2/3 and then 3 over 2 is the reciprocal. If I multiply this, 2 times 3 is 6 and 3 times 2 is 6. That equals 1. So when you multiply by the reciprocal, it automatically crosses out or cancels out the fraction that's in front. So if you look at this example, if we wanted to solve for m here, if we wanted to get m by itself, right now that's being multiplied by negative 1/4. What we can do is we can take this and we can do negative 1/4, m equals 8, and I can multiply over here by the reciprocal, which in this case would be negative 4 over 1. What I do to one side, I have to do to the other. So this crosses out because I'm multiplying there. And what I'm left with is m is equal to, well, 8 times negative 4 is negative 32. Just to kind of show you, if I was to substitute this back in, negative 1/4 times negative 32, that would equal an 8. So now if I have 3/8 times p, what I can do is multiply this times the reciprocal, 8/3, and multiply this side by 8/3. That crosses out, and I'm left with p is equal to, well, if you look here, I can cross cancel. That would be 1 and 5, so it's negative 5 times 8, which would be negative 40. And then this one here is 2/5 a. So if I want to get a by itself, I need to multiply by 5 over 2 over here. And what I do to one side, I have to do to the other. So I'm going to multiply by 5 over 2 over here. This crosses out. A is equal to, well, I can cross cancel here. I have 1 and 4. Then I have 1 and 3. So it equals 4/3. But should we leave that improper? I think we should probably change it to our mixed number as 1 and 1/3. So you can always, when you have the fraction out, when you're multiplying the fraction times the variable, you can multiply by the reciprocal in order to cross that out. Down here again, this is 3 times a. Remember, when you have your number out in front, your coefficient out in front of your variable. So to undo the multiplication, we're going to divide. And we're going to divide by 3. What we do to one side, we have to do the other. That crosses out because it's equal to 1. So then I have a is equal to, well, 12 divided by 3 is 4. Over here, if I wanted to get x by itself, I'm going to divide by negative 2. That crosses out because it's equal to 1. So I'm going to have x is equal to, well, 20 divided by negative 2 is negative 10. And then c here, I'm going to divide by 5 on both sides. So what I'm going to have here is y is equal to negative 8/5. And instead of using your calculator to figure this out as a decimal, let's just write it as a mixed number. So it's going to be negative, well, 5 goes into 8 one time with 3 left over. So y is equal to negative 1 3/5. So that's it for section 1 of chapter 2.